All right, welcome back. We are moving into our next unit, which is on loops. And the first loop that we're going to look at is a while loop. We'll do a little bit of coding. I'll probably do powers of two in a separate video. In computer science, if statements are extremely useful as they allow us to make decisions and alter the normal flow of a program. Occasionally, however, if statements fall a little short and the question is only asked one time. Let me show you what I mean. When validating user input, using an if statement, the program only checks the data one time before continuing. The user could simply enter an invalid input. Leap year, as an example. Here I am in the leap year class. We're looking at the main method. I am getting a year from the user. There are a lot of invalid years, right? I'm using an integer to represent this, so in theory, the user could enter any integer value. Right? Integers range from about a negative 2.1 billion to a positive 2.1 billion. And those are all acceptable answers for the user to put in. However, in terms of a year, a leap year, negative 2.1 billion doesn't make very much sense. In fact, negative years don't make very much sense at all. So we had an if statement check, in theory, to see if that year is negative. Right? In the event that the year is negative, I would tell the user that it is invalid and then have them enter a new year for me. However, this is an if statement, meaning the user could enter a negative year. We would ask, is that year negative? Yeah. We would tell them it's invalid. We would get a new year, but they could just simply enter a negative year again, causing problems, right? So this basically only asks the question one time, and that's not quite enough. Loops, such as a while loop, allow programs to repeat a section of code multiple times. Here is our syntax. Effectively, the stuff in yellow is required, where the white here, those are placeholders, if you will. So a loop is a type of control statement, the same category as if statements. Control statements are known for their ability to make decisions and alter the normal flow of a program. A while loop is similar to an if statement in several ways. We're going to have a head or header. We're going to have a body as designated by the braces. As with all control statements, the braces that indicate the body of the while loop can be omitted as long as the body contains only one statement. That is very rarely going to happen with our while loop, but it is technically accurate. The head of a while loop contains a condition. This is also very similar to an if statement. This condition must either be true or false, a Boolean value. When a while loop is executed, the condition is checked. If the condition is true, all of the statements in the body of the while loop are executed. That is literally copy and pasted from the if statement slides, and I've just replaced if statement with while loop. When a while loop is executed, we're going to check the condition. If it's true, we enter the body and execute all the statements. What is different is that once that body is done, it's executed, it's finished, we come back up and check the condition again. If the condition is true all over again, we'll enter the body and execute everything that's inside all over again. We're going to keep executing the body of the while loop as long as the condition is true. That is, we will stop once it is false. Visually, it looks something like this, right? We encounter our while loop, we check the condition. If it is true, we will enter the body, execute all the code, come back up, check the condition. If it's true again, we'll enter the body, execute everything that's in the body, check the condition again. And this keeps repeating, this keeps looping until we check the condition and it is false, at which point we would continue on with our code. In order for a while loop to work as intended, the condition should eventually evaluate to false. What do I mean? You kind of want to set up scenarios where this condition is true initially, and it's true for a while so that you get some iterations in, and then eventually becomes false and so that you stop. What that means is, in order for this condition to eventually evaluate to false, something has to happen in this body to make it eventually be false. You have to basically approach this condition. Generally speaking, the body of a while loop should contain a statement that is ultimately responsible for causing the condition of a while loop to evaluate to false. Okay. let's get some stuff under our belt. Suppose we want to know the sum of the first 100 numbers, beginning with 1. I want to know what 1 plus 2 plus 3 plus 4 all the way to 100 is. Our idea is we're going to create some type of variable to store our total, to keep track of our sum at any given moment. We'll add 1 to that, and then 2, and then 3. We keep going until we hit 99, 100, and that's the point at which we would stop. In order for this code to work, we're going to need to keep track of a few things. We need to keep track of our sum, our total, and we need to keep track of the current number that we want to add to that. So I'm going to create 2 integers. My sum, which is I'm going to use to track my total, and number is the next number to be added to our sum. Now it's a simple matter of adding number to sum and saving the result back into sum. So what one iteration of this, I shouldn't be using that term yet, but one iteration is I want to update sum. I want it to become what it currently is plus the new number. So I want to add number to sum, save the result back into sum, right? Right now we're looking at taking 0, adding 1. That gives me a total of 1, and that is the new value for sum. A while loop can be used to repeat this process. Right? With each iteration, every time I execute this body, I'm going to update sum to be what it was plus the next number. Once the current number has been added to our sum, we need to advance number to the next number so that we're adding 1 and then 2 and then 3, right? I don't want to keep adding 1. So after I add 1 to my sum, I need it to be 2 for the next time that we do this. So this can be accomplished by simply increasing our number by 1. After I update sum and make it what it was plus our current number, I need to update number. I'm going to make number what it currently is plus 1 so that the next time I do this, number is the next number in the sequence. The question then becomes, when should the while loop stop? So I've just been using the word condition as a placeholder. We haven't really talked about what the condition is because we need to first understand what one iteration, what one body looks like, and then we can kind of figure out where we want to stop. For our problem, the while loop should stop after we have processed 100 numbers. Right? When number is 101, I don't want to add that because what I wanted was basically the sum of 1 to 100 inclusive on both ends. So let's add a condition to this. Hopefully you can see that number is changing inside of this body. Right? Every time we do this, we update number, we increase it by 1, we save it back in. So every time this happens, number gets bigger and bigger and bigger and bigger. Eventually, number is going to be 101, at which point this would stop. This particular while loop will execute 100 times. With each iteration, sum will become what it was plus the current number. Additionally, number will increase by 1 so that on the next iteration, the next time we do this, number is 1 higher. Let's kind of go through a couple of iterations and see how this is working. Sum starts off at 0. Number starts off at 1. I'm going to encounter this while loop where we're going to check the condition. We're going to ask the question, is number 1 less than or equal to 100? 1 is less than or equal to 100. That is true. We would enter the body and execute this statement. I want sum to become sum plus number. 0 plus 1. That's the new value of sum. I'm then going to execute this statement where I want number to be what it currently is, which is 1, plus 1. The new value for number is 2. That's the end of the iteration. And what's different from an if statement is I'm going to come back up and check the condition again. We're going to ask the question, is 2 less than or equal to 100? That's true. So we would enter the body. We're going to update sum. It's going to be what it currently is, which is 1, plus number 2. The new value for sum is 3. I'm then going to update number. It's going to be what it currently is, which is 2, plus 1. The new value for number is 3. That's the end of the iteration. We're going to come back up, check the condition. Is 3 less than or equal to 100? That's true. Eventually, number is going to be 101, right? If I just keep adding 1 to it, it's going to be 101, and we would ask the question, is 101 less than or equal to 100? At which point we would get false, and we would skip over the body and continue on with the rest of our code. So eventually number will become 101, causing the condition to evaluate to false and terminating our loop. In theory, we could throw in a system.out.println line outside of the while loop to display the final value of the sum to the user, and this is the summation of the first 100 values. That is 1 through 100, inclusive on both ends. Let's throw this into Java and see it in action. I'm going to make a new project by going to File, New Project. We're going to go Next, Next, and you are probably already in the correct subfolder. I need to navigate to my Principles folder. And I'm going to make sure that we get a subfolder for this project. I'm calling it Sum 100. I'm going to expand my project folder, right-click on the SRC, and make a new Java class I'm calling Sum 100. I'm going to plug in a main method with PSVM. And we're going to need 2 integer values. My sum, which is going to be my total at any given moment. We're also going to need number, which is the next number that I want to add. So maybe these are good comments, right? The next number to add to sum. The total at any given moment. Right? Initially, before I start doing anything, my sum is nothing. It's 0. And the first number that I want to add to it is 1. Conversely, you could start sum at 1 and then make this 2, but I mean, that's just going to, where do you stop? I'm going to plug in my syntax for a while loop. It looks just like this. I'll be real honest with you. It's effectively the exact same thing as an if statement, right? Except Java knows to check this one more than once. With each iteration, I'm going to update sum. I want it to be what it currently is. I don't want to lose my progress as we go, plus the number. After I do that, I want to update number so that the next time through, the current number has been updated. This will keep happening, and eventually number will hit 101, at which point we stop. So I'm going to repeat this as long as number is less than or equal to 100. You could write this different ways, right? This could be as long as number is less than 101. That's the exact same thing. Why don't I leave this as a comment? Okay, what I'd like you to notice is that there is a statement inside of our while loop which causes us to approach this. So initially, this condition is true, but changes happen to number in the body that eventually cause it to be false. After this loop is over, I can print off the final value for sum, and that is going to be the summation of those first 100 numbers. I'm going to right-click in free space and tell it to run. And there we go. This is true. That is our answer. Okay, yeah, one thing I want to show you before I progress is a lot of times to students this is just like, okay, cool, you produced a number. But to kind of prove that this is happening over and over and over again, which, I mean, it should be obvious from our result, but what if we were to put a print statement in here, right? And we maybe, after we update our sum, we see what the value of sum is. Right? Just like with all these other statements, this is going to print every time this executes. And so what we're going to end up with is 100, 101 SOPs, print statements, here in our output. Now that's cool, right? We see the initial value of sum is 1, and then 3, and then 6. And so we can actually see it progress. If we look here at the very end, we see that is the final value. And this particular line was produced after the loop had finished. Now I'm ready to continue. As stated earlier, in order for a while loop to work as intended, the condition should eventually evaluate to false. However, it is possible for the condition of a loop to never evaluate to false. That is, the condition always to evaluate to true. A loop that contains a condition that always evaluates to true is known as an infinite loop. Here is an example, and this is probably the most common way that this would occur. I have a condition that depends on number, and initially that condition is true, right? 1 is less than or equal to 100. Now, if you forget to change number for whatever reason, well, it's just always going to be 1, meaning this is always going to be true. So let's demonstrate this idea real fast. I'm going to not do that. I'm going to comment this line out, which is the same as deleting it. In fact, IntelliJ gets very upset when you do that, kinda, because if you hover over this, it tells you, oh, this thing is always true. If I tell that to run, this will go indefinitely. Right? The only thing that could possibly break this is your computer just breaking, right? Just stopping. In theory, it could run out of RAM, and that would cause it to crash. In practice, you'll actually find that if you were to scroll back, it starts deleting some of the old information as there's just too much, meaning that this is actually freeing up RAM as it's going. So this will, in theory, just keep going until your computer just literally crashes. Infinite loops are usually unintended and the result of a programming error, but you could easily code an infinite loop for scientific reasons, right? An infinite loop happens as long as the condition is true. Well, you could literally just put the word true there. Says while true. Is this true? Yes. Okay, enter the body. Is it still true? Yes, enter the body. Okay, I'm going to plug that in. I think this may give me a literal syntax error, right? Syntactically, Java recognizes because that condition is true always that we can't quite reach this statement. I'm going to comment it out for scientific reasons. And I'm going to run our infinite loop that is knowingly infinite. Okay, again, this will go indefinitely until your computer crashes for whatever reason. And if you got like a legit machine, it just may never crash. One thing I'd like you to notice, and typically, like I said, infinite loops are unintended. A lot of times I'll get students and they'll have an infinite loop and they don't know they have an infinite loop and they just can't figure out why their program is not producing anything, right? Imagine that this SOP is not there. And if I take the SOP out, maybe you're trying to, figure out what's going on with your program and there's no feedback here, right? Without the SOP. There kind of is. I typically come over in that situation and look at this and recognize that there's that little stop symbol there. The only reason I can press the stop symbol is because the program is running. So looking at that, I would know that there is an infinite loop, and I can hit the stop and tell it to stop as such, right? If I bring back the system.out.println line, I tell it to run. Notice that our stop button is red, meaning we can press it, at which point it will stop our program and it will exit that loop, that sort of thing. Okay, that's going to be it for this one. This has been our introduction to while loops. I'll see you in the next one.